All right, good morning, students. It is Monday morning, and your assignment that was due this morning was pages 12 and 13, 10 through 36 even. So if you would get that assignment out, please, if you have it with you, and check your answers. I have them on the screen, numbers 10 through 36 even. And Mrs. Chambers, if you need to pause the video at this time until everybody gets their answers checked, that would be fine. Now that you've checked your answers, please note that if you took 7 to the third power and actually simplified it, that would be fine. Anything that is equivalent to an answer that is on the screen would be fine. And so I just want to check to make sure you've tried each one. And if you have any questions, put a question mark by the answer and we can talk about it more tomorrow. Now, if you'll notice the 5 that I have in red, I'd like for you to circle those 5, 12, 18, 26, 32, and 36. And please count how many of those 5 did you get correct on your own. Of those 5, please put that plus number at the top of your paper. Plus 5, plus 4, plus 3, plus 2, plus 1. Now you will get credit for trying each problem. You get a 100% in Sycamore as long as you, I'll go over with you more tomorrow as to how we keep track of our homework, but that will give us a good start. And then if you would give your homework assignment to Mrs. Chambers before you leave today, I can take a look and see how those papers look before class tomorrow. All right, here is your schedule for this week. If you want to jot this down in your student planner, due tomorrow, Tuesday, the assignment will be page 21, numbers 5 through 31 all. On Wednesday, you will have a quiz on the first 2 lessons in chapter 1. You also have an assignment, page 41, 7 through 20 all. Remember, there will be no class on Thursday because the high school is going to Fort Bluff for our retreat. And then on Friday, you'll have another quiz on lessons 1 through 3, as well as more problems on page 41, numbers 21 through 38. So you can jot down those assignments and note that we have 2 quizzes, and that way you're all ready for this week. You can pause the video if you need a little bit more time to write that down. The lesson we're going to go over today is chapter 1, lesson 3, called Solving Linear Equations. In order to get started and get back into the process of solving equations, we need to review a few terms, a few concepts, again, very fundamental to algebra. And the first one is to remember what an equation is. Last week we talked about expressions. Expressions would be numbers and terms that are being added, subtracted, multiplied, so forth, but there was no equal sign. Today we're getting back into equations, so remember an equation is a statement that 2 expressions are equal. Next, a linear equation in x is an equation in which x appears to the first power. A linear equation just has x in it. It does not have x squared, x cubed. It has no power other than just an understood first power. The graph of a linear equation is a line. We graphed a lot of lines in Algebra 1, and so we'll be returning to that, but just to help you get back into the understanding of what a linear equation is, it would just be a variable in the first degree. A solution of an equation is a number that when substituted in for the variable makes the equation true. A lot of times we call it the answer, solving for x, and so forth. It's just some basic terms that you will be using here in this lesson. All right, and then the other tool that you need to remember, the other tools would be the different transformations that produce equivalent equations. If you would write down these 6 concepts that when solving for equations, to solve for x or the unknown, the variable, you can do one of 6 things. The first thing is you can add the same number to both sides. Second, you can subtract the same number from both sides. Third, you can multiply both sides by the same non-zero number. It cannot be 0 because if you multiply both sides by 0, it will eliminate everything in the equation. In like manner, you can divide both sides by the same non-zero number. You cannot divide by 0, so that's why we have to stipulate what type of number can be multiplied or divided by both sides of the equation. Fifth, you can simplify one or both sides, and then finally you can interchange the two sides. So we'll be using these different transformations as we review solving equations. All right, the first example, if you would jot these examples down in your notes, here is the problem. 2/5 x plus 7 is equal to 13. And so we begin and we look at this equation and we think, what transformation can we do in order to accomplish our goal of solving for x? I already have the answer down here, but it's going through the process of, do you understand how we get x down here? So the first step here, when you have 2/5 x plus 7 is equal to 13, you want to think, what can I do with this negative or with this positive 7 to eliminate it from the left side in order to simplify the left side so only x remains. So what we do to a positive 7 is add the opposite. Add the opposite of a positive 7, which would be a negative 7, and notice I do that to both sides. I subtract the same number from both sides. Keeps the equation equivalent, but we begin to simplify. That gives us then on the left side 2/5 x, and on the right side 13 minus 7 is equal to 6. Simplifies it to just the number 6 on the right side. 2/5 x is equal to 6. Now I need to simplify so that there's only x, or a 1x on the left side. And as we talked about last week, one way to eliminate a fraction is to multiply the fraction by its reciprocal, or use the multiplicative identity. So the reciprocal of 2/5 would be 5/2, 5 halves. Multiply 5 halves times 2/5, and we know that any number times its reciprocal would equal 1, so 5 halves times 2/5 times x will just simplify to 1x on the left. Because I'm multiplied by 5 halves on the left, I also have to do it on the right. 5 halves times 6/1 really looks like this. My apologies, this is how the computer shows fractions, but really what I'm saying is 5/2 times 6/1. Now notice what you could do is you can just multiply straight across. 5 times 6 over 2 times 1, or you can cancel. 2 goes into 2 one time, and 2 goes into 6 3 times. So 5 times 3 would be 15. 5 times 3 is 15/1. That's how we got x is equal to 15. If you just multiplied straight across, numerator 5 times 6 is 30, denominator 2 times 1 is 2. 30/2 still reduces to 15. Example 2, we've got variables on both sides. 8x plus 15 is equal to a negative 4x plus 51. You got 8x plus 15 on the left, negative 4x plus 51. So my first transformation is I decided to get all of the x's over here on the left side. I've got 8x on the left, negative 4x on the right. However, the opposite of a negative 4x would be a positive 4x. So if I add two opposites together, negative 4x and positive 4x, they add together to give me 0. So 0 plus 51, that's how I got 51 left here on the right. And then 8x plus 4x is how I got 12x on the left plus 15. Then in red, from step 3 to step 4, I subtract 15 from both sides. Had a positive 15, so the opposite of positive 15 would be a negative 15. Subtract 15 on the left and subtract 15 on the right. The 15 and negative 15 cancel on the left, just gives me, all that remains would be 12x. 51 minus 15 is 36. 12x is equal to 36. Last step, if I have 12 times x, the opposite of multiplication is division, so I'm going to divide both sides by 12 to get 1x on the left, and 36 divided by 12 is 3. Also, a good thing to do is, once you get a final solution down here, take that 3 and substitute it back in for x in the original equation. Substitute 3 in for x right here. It'd be 8 times 3, 24 plus 15. and then substitute 3 in here. Negative 4 times 3 would be negative 12 plus 51, and just make sure that that answer makes both sides of the equal sign equal to each other. Just a little tip. That's always a good thing to do. Example 3, they add some parentheses, and you've got to, before you begin solving for x, you have to use the property of distribution that we were talking about last week. So from step 1 to step 2, notice I take 15 and multiply it by 1, and 15 times a negative x, and that distributes to be 15 minus 15x. And then negative 3 times negative x, and negative 3 times negative 2. That's how I get the black numbers here of 3x plus 6. And then from step 3 to from step 2 to 3, I work to get all of the x's together. So if I had negative 15x in the black, the opposite of negative 15x is to add 15x to the left, and that simplifies, so I just have a 15 on the left once I add the two opposites together. And then on the right, 3x plus 15x is 18x plus 6. From there, I decided to eliminate my positive 6 from the right, so I add the opposite of a positive 6. I add a negative 6, or subtract 6. Notice adding a negative 6 and subtracting 6 are the same thing. So I kind of use those operations interchangeably. But if I had a positive, now I'm going to subtract 6 from both sides. So you can see the negative 6 on both sides. 15 minus 6 is a 9. And 18x basically plus 0 is just 18x. And then because the 18 is being multiplied by the x, or it says 18x, that's how you know which one to divide by. You would not want to divide both sides by 9, because then you still will have a coefficient in front of x. So always divide by whatever is in front of the x. It does not matter which side of the equal sign x is on, but in order to get 18 over 18, which reduces to 1x, you would want to divide by that same coefficient. And then what I did, if I divided the right side by 18, then I need to divide the left side by 18. Actually, 9 over 18 will just be a fraction that reduces to 1 over 2. So my final answer is 1/2 x. Okay, the final example is a little bit more of a complicated problem. This is going to be more representative of Algebra 2. So I'm going to go through the process here, and you just follow through. What I would recommend is to write this down and see if you can follow through with me, and then we'll get into more complicated problems like this on Tuesday when I return to class. All right, you're going to distribute 1/3 times both terms in the parentheses here. 1/3 times 14x, that's how I got 14/3 x, and 1/3 times 9. That would actually be 9 over 3, or 3. So 1/3 times 9 is 9 divided by 3, or 3. On the right side, you keep the 11. For now, we don't have to do anything with it. You're going to take the negative 5 and distribute it times the x, and negative 5 times the negative 3. So on the right, I have 11 minus 5x plus 15 after I distribute. 14/3 x plus 5x plus 3. I need to add those two together. 14/3 x and 5x. To be able to add these two coefficients together, we have to have common denominators, because the 14/3 is a fraction. (14/3) plus 5, the way that we do that, get them in common denominators. 14/3 already has the denominator of 3. So if we're going to change 5 over 1 to thirds, this is the way that your elementary teachers taught you to do it. You're going to change 5 over 1 to something over 3. So because we multiply 1 by 3 to get this denominator, we need to multiply 5 by 3 to get a numerator of 15. So to change to common denominators, we need both fractions to have a common denominator of 3. 1 times 3 is 3, so 5 times 3 is 15. And then I took 14/3 plus 15/3, and that's how I got the 29/3 right here. once we have common denominators, there was a positive 3. I needed to subtract 3 from both sides. So notice here was a minus 3, and here's a minus 3. 26 minus 3 is 23. And I'm not sure if I mentioned the 5 that we added the 5x. Yeah, that's how I got over here. All right, so anyway, 14 thirds x plus 15 thirds plus 3 minus 3 is equal to 26 minus 3. This simplifies on the left to just be 29 thirds x, and then 26 minus 3 is 23. Final step, 29 thirds x is equal to 23. And then the final thing, all that I did right here was I just multiplied by the reciprocal of 29 thirds, or 3 over 29. 3 over 29 times 29 thirds is 1x. 3 over 29 times 23, here's what it looks like. 3 over 29 times 23 over 1. And when you multiply across here, 3 times 23 is all right, 3 times 23 would be 69 23rds. There's your final answer, 69 over 29. All right, your assignment is page 21, 5 through 31 all. And let me just go through the instructions here. If you turn to page 21, and I think you've already written down the assignment, let's just go through the different instructions for each section. The first 2 sections are pretty easy, but I thought if I don't give you an example, you may not understand what they're actually looking for. So if you look at the instructions on page 21 for 5 through 10, it says in exercises 5 through 10, describe the transformations you could use to solve the equation. So here's just a real simple one. If you have the equation x plus 12 is equal to a negative 10, what you're going to do is you're going to subtract 12 from both sides in order to get the answer of x is equal to negative 22. Now notice they're not asking for the answer, they're saying describe the transformation you could use. So the answer for this problem would be the transformation is to subtract 12. So this is the answer, although solving for x would be a negative 22. You don't have to solve for the variable, you just need to give the answer that the transformation is subtract 12. In exercises 11 through 16, notice it says check whether the number is a solution of the equation. And here would be an example. Here's the equation, 10 plus 2x is equal to 22. And then there will be a comma and a number. And what they're asking you to do is take this number that follows the comma to the right, the number following the comma over on the right, and substitute it into the equation for the variable. And then just check to make sure the left side equals the right side. So once I substitute 6 in here for x, substitute it in, and then 10 plus 2 times 6, since that expression right there will equal 22, the left side equals the right side, therefore 6 is a solution for this equation, and you would give an answer for your homework of yes, it is a solution of the equation. Then 17 through 22, it says solve the equation. So that would be where, yes, you are solving for x right here. You'll write the equation down, make sure you show your work. Notice 2x plus 10 is equal to 12. Subtract 10 from both sides. You can cross off the positive 10, showing that only 2x remains on the left. 12 minus 10 is equal to 2. 2x is equal to 2. Divide both sides by the whole number 2, and 1x is equal to 1. And then the final problem here in exercise, or the final section in exercises 23 through 40, solve the equation, check your solution. Now you're not going all the way through 40. I'm just saying that's what the instructions read. You only go as far as the assignment today. We will do some of the harder ones in class together, Here would be an example, one of the harder ones, where you would go 4 times x is 4x. 4 times negative 3 is negative 12. Negative 2 times 9 is negative 18. Negative 2 times negative 8x is a positive 16x. Then I work to get all the x's to the same side of the equation. And I have a 4x right here, so I start out by subtracting 4x from both sides. I underlined the 4x's. The 4x minus 4x eliminates the x's on the left. I'm just left with a negative 12. Negative 18 plus 16x minus 4x. I combine these two x terms together, and I'm left with negative 18 plus 12x. I take this negative 18 and add 18 to both sides, do the opposite of to eliminate the negative 18 from the right. I'm left with negative 12 plus 18 is equal to 12x. That's how it comes down to 6 is equal to 12x. And then divide by the coefficient in front of x to solve for 1x. So 12x over 12 just reduces to 1x, and 6 twelfths. There, you can see it a little bit better. Divide both sides by 12. And that's, you should be able to see how we got the final answer of x is equal to 1/2. All right, that's a little bit more complicated than the ones that you will have to do for homework, but that's what we mean by show your work. And hopefully the process, the transformations after watching the video today have been brought back to your remembrance, and with some practice over the next week or so, you're going to be doing very well with your equation solving. All right, you may begin working on your homework. Use the rest of the time in class to complete your homework. You may begin.